Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I am Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So today I'm going to discuss JEE main paper of 3rd September, which was held in first shift. Alright, so I've got all the questions. They are memory based, but yes, all 25 questions. I'm going to discuss these questions today in this session. Alright. So stay with me and let's start the discussion. So maths paper was like this. Let's start the discussion and then we'll see how many questions are easy and how many questions are of moderate level and which questions are actually difficult or lengthy. All right. So this is the first question, which is based on limits. All right. You can see in this question, modulus is there, modulus and greatest interior function. So two functions are used, modulus and greatest interior function. So that means whenever you have modulus function, piecewise defined function in a question of limit, that means you need to find left hand limit and right hand limit separately. And if limit does exist, then both the limits must be equal as well, right? So limit does exist in this, it is given L, all right, and we need to find the value of L. And you can see, so let's start with finding the left hand limit and then right hand limit and we'll equate them. One more parameter is there. You can see lambda is a parameter in this question. So we'll try to find the value of lambda also because that might be required before finding L. All right. Okay. So let's start finding left hand limit first of all. So for left hand limit, you need to put 0 minus h in this question, right? When x is equal to 0 minus h. So h approaching to 0, this will be mod of 1. If you put minus h, it will be plus of h because minus x is there, plus mod of minus h is h only, right? Divided by, it will be lambda, minus of minus h is again plus h, and greatest integer of minus h is minus 1. All right, so mod of this, greatest integer of minus h is minus 1. All right, so using this we can write, now you can put h is equal to 0 because this is not indeterminate, okay, and lambda is not 1, it is given in the question, so denominator will not be 0, denominator is not approaching to 0. So it will be 1 upon, uh, but in denominator you can't remove modulus because you don't know whether lambda is more than 1 or less than 1. Okay, so let's keep it in this way only, and then we'll solve the right hand limit and we'll equate these left hand and right hand limit. So for right hand limit, you need to put x is equal to 0 plus h. Okay, so put x is equal to 0 plus h and h approaching to 0. This question will become 1 minus h, and mod of h is h only, divided by lambda minus h, and greatest integer of h is 0 plus h. All right, so now you can put the value of h, which is 0, so it will be 1 upon mod of lambda. All right, so after putting h is equal to 0, you'll get 1 upon mod of lambda. So you've got both the limits, but in terms of lambda, so let's equate them and try to find the lambda. So, and this is equal to L also. Left hand limit is equal to right hand limit is equal to L. So we'll solve this. 1 upon lambda minus 1 mod is equal to 1 upon mod of lambda. And after equating, just you can open the mod. So lambda minus 1 can be written as plus minus of lambda. So if you take plus sign, you won't get any value of lambda. But if you take minus sign, you'll get 2 lambda is equal to 1. That means lambda is equal to half. All right. So if I put lambda is equal to half in this equation, okay, this is L also, so you'll get L is equal to, if you put lambda is equal to half in this, so you'll get L is equal to 2. All right, so 2 was the correct answer in this. So 2 was the correct answer in this. So this was not very easy problem, not difficult, but yes, it's a good conceptual problem because you need it involves greatest interior function and modulus function as well, right? And good concept of limit, left hand and right hand you need to find separately. All right, so this is a better problem. All right, not easy one. Now we have second problem of hyperbola. In this hyperbola, a hyperbola whose length of transverse axis is given root 2 and is confocal with an ellipse, all right, then which of the following does not lie on the hyperbola? All right, so you can solve this question by finding the foci and all, then equate them in hyperbola, and transverse axis length b is already given, so you can find a. All right, and then you can write the equation of hyperbola. But let me tell you another method. Okay, any hyperbola which is confocal with this given ellipse, x square upon a square plus y square upon b square is equal to 1, can be written as x square upon a square minus lambda plus y square upon b square minus lambda is equal to 1. Just subtract a constant from these two and you'll get a curve which will be confocal with this as well as it will be orthogonal as well, right? So you just need to take minus common because lambda should be greater than by b square and should be less than a square. So then in this case, you'll get a curve which is hyperbola as well, right? And confocal with this ellipse. If lambda is less than b square and less than a square, then it will be an ellipse confocal with the given ellipse, all right? So I'll write the equation of required hyperbola, which is x square upon 4 minus lambda plus y square upon 3 minus lambda is equal to 1 because it's a hyperbola, so lambda should be greater than 3 and less than 4, all right? This we know. If you know this particular form, then we can use it. So x square, let's write this in the form of equation of standard hyperbola, y square upon lambda minus 3, all right, is equal to 1. Now you can see b square is, so b square is this b square, b is given root 2. So b is given, so b square is this, right? Length of transverse axis 2b is given root 2, sorry. So b square is lambda minus 3. From this you'll get b is equal to um, b is equal to what, under root of lambda minus 3. And now equate with the given 2b is equal to given root 2. So if I equate them, so 2 times of under root of lambda minus 3 is equal to root 2 and solve it. So solving it, you'll get 2 times of, you can cancel this 2. So it will be 2 times of lambda minus 3 is equal to 1, all right? So finally, what is the value of lambda? So you can get 2 lambda minus 6 is equal to 1. So lambda is equal to 7 by 2. Lambda is equal to 7 by 2. So if you put lambda is equal to 7 by 2 in this equation, all right, 7 by 2 in this equation, you'll get equation of the hyperbola. Put this, the value of lambda in this. So it will be x square upon, if you put 7 by 2, 4 minus 7 by 2 is half, minus y square upon 7 by 2 minus 3 is also half, okay? So this is the equation. So we have got the equation of the hyperbola, okay, without finding focus and all. You just need to know about this relation for confocal curves. Now you just keep checking the points. If you take 1 comma 1 by root 2, if you put x is equal to 1, it will be 2. First term will be 2. And if you put x is equal to 1 by root 2, the second term will be 1. So 2 minus 1 is 1. So first will satisfy, but you need to find a point which does not satisfy. If you put 3 by 2 comma 1, so it will be 3. First term will become 3 and second term will become 2. Alright, so this also satisfies. If you put this third point, so it will be 3 by 2 squaring, after squaring 3 by 2 upon 1 by 2, that is 3, and if you put 1 by root 2, so that is 1. So 3 minus 1 is 2. So this point does not satisfy, alright. So 3 is the correct answer. So this was a good problem actually. Good problem, but if you do it finding the focus and all, so then you can solve it easily. Okay. So I have done it using a good method, which might save your time, all right. But you can do it using finding foci also, foci of the ellipse, and then make it confocal with hyperbola, and then you can do it. Okay. So that way you can use like method of boats and all. Now this was a problem from hyperbola, no sorry, probability. So a die is rolled twice and sum is noted to be a multiple of 4, okay? Then probability of getting the score of 4 at least once. So it is given that sum is a multiple of 4, all right? So it's a conditional probability. So let's write the sample space. Both problems of probability were actually based on conditional probability. In this we can write the sample space. So after reading this condition, sum is noted to be a multiple of 4. So that means sum can be 4, 8 or 12. It is already given. So sum can be 4 when a die is rolled twice or 2 dice are rolled simultaneously. Both are same thing. So on first die it might be 1 and on second die it might be 3, 1 comma 3 or 3 comma 1 also. First die 3, second die 1. And how or what is the other way of getting 4? 2 comma 2, all right? So this is for getting sum 4. And if you're getting sum 8, because sum is a multiple of 4, so sum can be 8 also. So you can get 2 comma 6, first die 2, second die 6, or first die 6, second die 2, all right? And then you can get another way of getting 8 is 3 comma 5, so 3 comma 5 and 5 comma 3, all right? And 4 comma 4 as well, right? So 4 comma 4. So these are all possible ways of getting 8 and getting 12. 12 is like there's only one case, 6 comma 6, all right? No other case. So you can see how many sample points are there in your sample space. You have 9 points, okay? Now your favorable event is scoring 4, let's take it A, okay? Score is at least, okay, getting the score of 4 at least once. Okay, so you can see in how many pairs you're getting 4. One or on one die or both the dice. So you can see there's no 4 in any of the pairs except this one, only this one. And here you're getting 4 on both the dice. Okay, so this is the only sample space you have. You need 4 at least on one die. So you have only one such case in which you are getting 4 on both the die. So you have one favorable case and total case is 9. So probability will be P of A, if I write, will be 1 by 9. So this was pretty simple question. Very easy question. Like in the beginning you do this, okay? Although it is of conditional probability, but if you know conditional, then this is very simple problem. Well, very simple. Now we have another problem of probability. This was a good problem, all right? This was a good problem. A bag contains 6 red balls and 10 green balls. So let's write this. 6, this is bag number 1, and 6 red balls and 10 green balls. So 10 green balls, this is bag number 2. 3 balls are drawn one by one without replacement. If third ball is drawn from the bag is red, then probability that first two balls are green. All right. So now it is again a conditional probability. Third ball is given red, then you need to find the probability that first two balls are green. All right. So let's write the sample space. What are the possibilities? I am writing in terms of color of ball. All right. So third ball is given red. So third ball is red. Now first two might also be red, right? Now it might be the case that first is red, second is green, but third is red, right? It might happen that first is green, second is red, and third is also red. Then it might also happen that first is green, second is green, and third is red. So these are the four possible cases in which third ball will always be green. Sorry, red. This is your sample space. This is given. That means these uh, one of these four events has happened, right? So these are the possible events. Now, what is your favorable event? Your favorable event, you need to find the probability that that first two balls are green. That means this is your favorable event, right? So you know what is the probability, conditional probability P of A. You need to find the probability of A when S has happened, right? It is given. This S has happened, right? Otherwise, there might be some other cases also like green, 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 red, green, green, right? Those cases are excluded now. So this S has happened and you need to find the probability of A. So this is P of A intersection S divided by P of S, all right? So P of A intersection S is nothing but this only because this event is common with this, right? Out of 4, one of this event is happening. So that means green, green, red, this you need to write the probability of this event divided by probabilities of this R plus R green R plus green R plus green green R, all right? So this was the proper way of doing this. Now green, green, red. Now let's write how to get green, green, red. So for getting first green is 10 by total balls are 15, right? Now second green is 9 by 14 balls are left. Now one red, so all 6 red are there, but total balls left are 13, all right? So this is the probability of the numerator divided by, let's write the probability of the denominator. So first ball is green, first ball is red, so 6 by 15, then 5 by 15, all right, and into 4 by 15. This is the probability of getting 3 red balls plus first red, so that is 6 by 15, second green, so it is 10 by 14. Oh, I'm sorry, I did this mistake here. That is the main thing actually in this question. You do denominator is also always going to be same 15, 14, 13. Okay, so you can cancel this denominator. It is going to appear in all the terms in numerator as well as in denominator. Okay, so I'm not going to write this denominator again and again. Directly just write these numbers. Okay, so 6, 10, and then 5 because third is always red. So denominator is same. So now this third case is green, red, red. So 10, then 6, then 5. All right. Denominator is same. Then you have green, green, red. So 10 into 9 into 6. All right. This is same. This you can cancel. This you can cancel. And you can write the remaining numbers. So required probability is 10 into 9 into 6 divided by, it is 6 into 5 into 4. All right. Plus 6 into 10 into 5 plus you have 10 into 6 into 5 plus 10 into 9 into 6. All right, let's simplify it. See if any number is common. So yes, you can take 10 common. 10, you can say 10, 10, 10, and here also you can make 10. So let's cancel 10 first of all. Okay, let's cancel 10. So this, if I cancel, only 2 will be left in this. All right, now what else we can cancel? I can cancel 6 as well. So let's cancel 6 also. So 6 is cancelled, 6 is cancelled, 6 is cancelled, 6 is cancelled. All right, now let's write the remaining number. It is 9 upon 2 is left here, 2, and plus 5 and plus 9. All right, 9. So let me write if I have left anything. One more number should be there. Yeah, 5, 5, one more 5. Third term is 5. All right, so this is 9 upon, you can say, is 21. So this is, if you cancel 3, 3 by 7. This is the answer. All right, so 3 by 7 is the correct answer in this case. So I hope it is clear. This was a good problem. This was not easy, not, you can consider this as slightly difficult. All right, so slightly difficult if you do it. But in some cases, some students has done it wrongly also, which is the wrong method, although they have got the correct, I mean, they have written the probability of getting the third ball as red, 1 upon 1, and first two balls greens. So that is 6C2 divided by 15C2. All right, although this is also giving 3 by 7, but this is the wrong method. Okay, this is the wrong method, you can't do this. Okay, this is a conditional, you'll have to divide by the probability. By chance, in this case, you are getting the right answer using this wrong method also. All right, so now let's move to another problem, question number 4. Yeah, so this is a good problem, and I've seen that in most of the places question is given, answer is given 17, but yeah, I'm getting 16.5. I'll tell you how. So let's see if this method, numbers are written in increasing order: 4, 10, x, y, and 27. All right, increasing order. So whenever numbers are written in increasing order, then term in the middle represents the median. So median is x, and x is given how much? 18. So median of the data is given 18, so x is 18. So now we have got numbers 4, 10, 18, and then y, and then 27. Now deviation about the mean. Deviation about the mean is, you just take the difference of all the elements from its mean and take the average of that. All right, is given 7.6. All right, the mean of the data we need to find. All right, so mean of the data, if you write x bar, that will be, just add all these numbers. So if you add all these numbers, this is 14 plus 18 is 32. 14, 14 plus 18 is 32 plus 27. 32 plus 27 is 59. So 59 plus y divided by, total you have 5 numbers. All right, so this is x bar. But if I write the deviation about the mean, so that will be x1 minus x bar mod plus x2 minus x bar mod. We take modulus also. All right, whenever we write deviation. Standard deviation is this different thing, but in mean deviation about the mean, or deviation about the median, or deviation about the some other thing mode, then we take the difference of all the data from that particular mean and take the summation of absolute values of these numbers. So if I write the deviation about the mean, it will be 4 minus x bar mod plus 10 minus x bar mod plus 18 minus x bar mod plus y minus x bar mod plus 27 minus x bar mod. Now there is a very, very important fine point here to notice. See, even if I take, see, y lies between 18 and y lies between, we don't know whether where's this x bar lying, whether it is more than 18 or less than 18, more than 10 or less than 10, right? But we can figure it out from this equation. If I take the least value of y, which you can take 18 point something, because numbers might not be an integer, so just consider 18 as well, right? So that will be the least value. If I consider 18, so it will be 59 plus 18 by 5, and that will be 60 plus 77, right? So it will be 77 by 5, which is more than, if you divide, then this will be 14, 15 point something. So it is more than 15, right? So x bar is certainly going to be more than 15 point something. All right, or you can say more than 16, 17, 18, right? So it is certainly more than 16, And if I take the maximum value, which can be 20, slightly less than 27, so let's take 27 only, okay? So if I take 27, then it will be 59 plus 27 by 5. So if I add them, then this will be 70, 80, 86 by 5, which is going to be uh, 17 point something. That means it cannot exceed 18. So now we have got that x bar is certainly more than 10 and less than 18, right? So now we can open this mod. We can open this mod. So it will be, because x bar is greater. So x bar minus 4 plus x bar minus 10. But this will be 18 minus x bar, and certain y is greater than 18. So it will be y minus x bar and plus 27 minus x bar. All right. Divided by 5, and this was given equal to how much? This was given equal to 7.6. All right, now simplify it. So x bar, x bar, x bar, and x bar will get cancelled. You can put the y value of y in terms of x bar. So it will be 5x bar minus 59. All right, so add these numbers: minus 4, minus 10, 18 and 27. So it is and then I'm writing the value of y first of all. So y is 5x bar minus 59, and add these numbers: minus 4 minus 10 is minus 18, minus 14 plus 18 is plus 4, and plus 4 and plus 27 is plus 31. All right, plus 31, and minus x bar is also there, divided by okay, let's cross multiply. 5 multiplied by 5, so it will be 38. All right, now you can see it will be 4x bar, and what is this number? This number is going to be, if I subtract 31, it will be minus of 36, 28, I think, yeah, 28 I'll get. So 28 and plus 38 if you add, so it will be 28 plus 38, 28 plus 38, 28 plus 38. All right, so it is going to be 50, 60, 66, 66. All right, so x bar you're going to get 66 by 4, that is 33 by 2, 33 by 2, so it is 16.5. So I'm getting 16.5, and I hope you can guess this easily. This is very logical question. Opening mod was very important in this. This is one of the finest problem of statistics I have seen so far in JEE main exam. All right, it's a very good problem actually. In JEE main paper standard, if I see, this is a very good problem. All right, very good use of modulus. So answer should be 16.5 of this question. All right, let's move to another problem. This is again a problem which is based on roots of a quadratic. Yeah, one expression, symmetric expression of alpha and beta is given, and you need to find the value of this symmetric expression of alpha and beta. Let's write the values of alpha plus beta and alpha into beta from these equations. So alpha and beta are the roots of this equation. So alpha plus beta you can write is minus p, and alpha into beta will be 2, right? From the second equation, 1 upon alpha and 1 upon beta are the roots. So 1 upon alpha plus 1 upon beta you can write is equal to, is going to be 2 minus 2q upon 2. So it is going to be q, and 1 upon alpha into beta will be 1 upon 2. So yes, it should be, these two are basically same. From first and second, and from first and third, you in fact you can find, you can relate p and q. See how to relate p and q. This will be alpha plus beta upon alpha beta, which is 2, is equal to q. All right, so alpha plus beta will be 2q, and you can write minus p is equal to 2q. So if required, you can use this, because answer is given in terms of p as well as in terms of q. Now let's simplify this. Alpha plus 1 upon beta, the given expression is beta plus 1 upon alpha into alpha minus 1 upon alpha into beta minus 1 upon beta. All right, let's open this. We'll open these two and these two. All right, because they are similar expressions. So alpha into beta plus 1 upon alpha beta plus 1 plus 1 2. All right, and if I open this, I'll get alpha into beta minus alpha upon beta minus beta upon alpha, and minus 1 upon alpha beta. All right, plus 1 upon alpha beta, I'm sorry. So let's put the value of alpha into beta and alpha plus beta. So it will be 2 plus 2 plus 1 by 2, which is 4 plus 1 by 2, and 4 plus 1 by 2 is 9 by 2. Okay, so it is 9 by 2. This value is 9 by 2. And the second expression is this 2 minus, if you take alpha beta LCM, then it will be alpha square plus beta square upon alpha beta, and plus alpha beta you can put 2. So let's put it 2 here only. This is going to be 2, and then again 1 by 2. All right, so we can take LCM, and 9 by 2, it will be, after taking LCM, it will be 4 plus 1 5 minus alpha square plus beta square can be written as alpha plus beta whole square. So alpha plus beta whole square is basically p square, right? So I'll write it here, alpha square plus beta square in terms of p is p square minus 2 alpha beta, so that will be 4. All right, yeah, 2 alpha beta. So this value is going to be p square minus 4 and plus 1 as well. 1 minute. 4 plus 1. 1 I have already added. This was 4. This here. Yeah, I'll write it separately. Then we next step we can club it. So this after taking LCM will be 4, and this will be 1. All right. This whole divided by 2. So now you can write the answer. So final answer I'm writing here. It is 9 by, you can take 2 into 2 will be 4. All right, and inside it will be 4 plus 4 minus 1 is 9 minus p square. Okay, even if you replace it p by q, then p is basically minus 2q, it will be 4q square. So in one option it is minus q square only, so minus 4q square, 4q square is not there. So this A will be the correct answer, 9 by 4 into 9 minus p square. All right, so this was pretty straightforward question, although slight calculation is involved, but yes, you can do it in 2 minutes. All right, so this was easy to moderate, you can say. Now this was again a good question from binomial theorem. So this has 33 integral terms, then the least value of n we need to find. All right, let's do it. So in such cases, we generally write the general term TR. So TR is NCR, all right, and 2 raised to 1 by 2 n minus r, so it will be n minus r by 2, and 5 raised to r by 8. All right, so from this, because you need all the terms integers, so this must be an integer and this must also be an integer, right? So r by 8 should be an integer. That means r is equal to 8k type. All right, 8i or 8k multiples of 8. So when r is 8k and n minus r should be divisible by 2, so n must be an even number. So n is an even number. All right, n is an even number and r must be of 8k type. All right, then this will make both the terms, this whole term, an integer. All right, so whenever r is 8, 16, 24, 32, right, you'll get integral term. But when r is equal to 0, let's check it. When r is equal to 0, what will happen? And n is even. So when r is 0, n is even, yes, this will be an integer and this will also be an integer. So for r is equal to 0, you are getting an integer term. All right, and for r is equal to 8 and then 16 and then 24 and so on. Okay, after every eighth term is integral term. So what should be the value of n? If you take n is equal to say 32, so it will end at n r is equal to 32. I mean last term will be for n is equal to 32, and you'll get 8 in just divide 32 by 8, it will be 4. So 4 terms plus 1 term for 0, r is equal to 0. So total 5 terms. All right, so if you need 33 terms, then 1 term you have got for r is equal to 0, and remaining 32 terms for you'll get when it is 8 into 32. N is 8 into 32. All right, the multiple of 8 should be 32 in the expansion. So how many terms you need? Just multiply it. It is 256. All right, 8 into 32 is 256. So if you take n is equal to 256, you'll get 33 multiples of 8 including 0. All right, you can take 257 also, you can take 258 also, right? But you need the least value of n, so that's why it should be 256. But if it is less than 256, 255, then one multiple of 8 will be, less. It will be 32 multiples, and you won't get 33 terms. So I hope it is clear. This was quite a logical question. It's a good question. I won't say it very easy. It's very easy because this logic is involved. Calculation is not there, but logically it is very good question. All right. But we do such questions in binomial theorem, right? We always do such questions in which we find rational terms or integral terms, right? By doing this method. All right. So, but it was pretty straightforward because most of the students solve this question while doing the binomial theorem. All right. Now this is a question of definite integral. Let's see if we can do it. So minus, let's see, I mean, whether it is easy or difficult. Minus pi to pi, pi minus mod of x and mod. So whenever you have limits from minus a to a, you generally check for an even function, even or odd. So yes, this function is an even function because if you replace x by minus x, it will remain same, all right? So you can write immediately 0 to pi. This is pi minus mod of x whole mod. Now because x is positive, so mod of x you can remove and you can write only, uh, you can only write this pi minus x mod, all right? In fact, you can remove pi minus x also because x is less than pi. You can write pi minus x. So I'll do it using area. This is the graph of pi minus x. This is pi. You need to integrate it. This is also pi, all right? So you need to integrate this. So this will be the area of this integral, right? And this is pi into pi by 2, so pi square by 2. So it's 2 into pi square by 2 using the application of area geometrical. So answer is pi square. This was pretty simple, all right? I'll say this one was one of the easiest problem of the paper, all right? Or even you can integrate, all right? Just remove the mod and integrate it. It's very easy. Now let's do this another problem. This is from area only. Area enclosed by given curves, all right? So let's draw it. So first of all, let's make the axis. One minute, guys. Whenever there's a question from area under the curve, first of all, you need to draw all the curves properly and then first of all figure it out which is the required area by the given conditions, all right? Because most of the students do this mistake there only, all right? So first you need to draw this curve, y is equal to, just take the equality, y is equal to x square plus 1. So y is equal to x square plus 1 is a parabola, you all know that, right? It will pass through 0, 1. So this is a parabola. Y is equal to x square plus 1, all right? Now, y is less than this and greater than 0. That means y is below this parabola, all right? Below this parabola. If y is greater than x square plus 1, it will be above this yellow part. And if it is equal to, then it will be on the yellow part. So we are lying here below this from the first inequality, all right? Now, second one is y is less than this line as well. So what is this line? If I see this line y is equal to x plus 1, it is passing through this same point 0, 1. So you can draw this line like this. Let me use some other color. All right. So line is like this. And where will this, solve it and find this point first of all, where this line is cutting this parabola. So x plus 1 is equal to x square plus 1. And you can see x is equal to 0 or 1. You're getting 2 points. So this point is 1, 1 comma 2. This point is 1 comma 2. But you need to, okay, so first of all, let's see what is this representing. This is representing the region below the line, all right? So this below green line, and from the first equation we have below yellow line. So now we have got this, not this one, all right? This won't be there because it is above the yellow part, so leave that. Okay, we need to take intersection. Now let's write the third one. So third one is x is greater than 1 by 2. So let's draw the line 1 by 2. So 1 by 2 will be somewhere here. Let me use, so 1 by 2, this is x is equal to 1 by 2. So x is greater than 1 by 2. That means x is right side of this, all right? And less than 2. So less than 2 means this one. So x is equal to 2 is this, is left side of this, all right? So total required area is basically this, all right? Basically this. I'll draw this line here because you can see this is 1, this is 1 comma 0. So from 1 by 2 to 1, you need to integrate this yellow part. Yellow means parabola. And then this is a trapezium. You can write whether you integrate or you can directly write the area of the trapezium. So I'm going to write the area. This will be area from 1 by 2 to 1. You need to integrate what? X square plus 1, all right, dx, and plus area of this trapezium. So area of this trapezium is, this point is 2 comma what? Just put 2 in this, so you'll get 2 plus 2 comma 3. So you know this side is 3, this side is 2, so 1 by 2 sum of parallel sides 2 plus 3 into distance between the parallel side, which is 1, all right? That's it, done. Now let's integrate this. So you'll get x cubed by 3, so that will be 1 by 3 if you put the upper limit, plus x, so that will be 1, minus x cubed by 3, so put 1 by 2, so that is 1 by 3 into 1 by 4 as well, right? Minus x, so if you put 1, so it will be 1 by 2. So this plus you're getting 5 by 2, all right? So now write all these numbers, I mean take LCM and all. So if you take LCM, it's 12 in this case. If you take LCM 12, then it will be 4 plus 12 minus 1 minus what? Okay, I missed 3 in this, all right? 3 will also be there. What? No, I'm sorry. 3 will not be there. 3 will be only with this term, all right? First term. 3 is in this, x cubed by 3 and x cubed by 3. This is only x, all right? So it will be minus what? Minus 6, I think, yeah, minus 6. So this plus 5 by 2, all right? Let's simplify it. It will be 12 plus 4, 16, minus 6, 10, minus 9. So it is 9 by 12 plus 5 by 2. All right, so let's make it 6, multiply and divide by 6. So it will be 39 by, let me check the calculation first of all. X cubed by 3, 1 plus 1 minus, if I put 1 by 2, so it will be 1 by 3 into, oh, actually, yeah, I did this error here. This will be 1 by 2, not a square. So it is 1 by 2. Okay, now calculate it again. So it will be 2 here, right? 2. This part will be 2. This part will be 2. And then 6, all right. Now what are we getting? 8 upon 6. 1 minute. Oh, sorry. It was actually x cubed by 3, so I think I did, yes. Let me correct it. This is the error. So I'll correct it. It was x cubed by 3. So when you put x is equal to 1 by 2, it will be 1 by 3 into 1 by 8. All right. So after doing this correction, let me take LCM again because that is the main thing. And then we are done. All right. So this is almost done. All right. So if I take the LCM, which is actually 24 now, 24, then it will be 8 plus 24 minus, this is 1 only, all right, and this will be minus 12, all right, plus 5 by 2, all right, plus 5 by 2 is equal to, now let's simplify it, so this will be 12 plus 8, 20, 19, so it will be 19 upon 24, all right, plus 5 upon 2, so let's make 24 in the denominator here also, so 24 multiplied by 12, so it will be 60, all right. So now 60 plus 19 is 79 by 24, all right. So this was the correct answer, 79 by 24. So this was the problem based on the area, all right. Some calculation was involved in, and this is a very, very good problem because mostly students do not get which area to find. They generally mistake with this. They might find this area bounded by these two curves, all right. So that might be an error in this case. You can see many other at other places also area is bounded, all right. So let's move to another problem. This is based on calculus, differential monotonicity. You need to find the interval in which this is increasing. All right. So it is 2 by 3. All right. 2x minus 1 raised to 2 by 3. Um, I think let me check first this problem if this is correct, because we just need to differentiate in this, and after differentiation we can do it easily. Let me check this once before differentiating if it is typed correctly. One minute guys, just 1 minute. All right, so there's one correction in this. This is 3x minus 7. It is not typed properly. X raised to 2 by 3. Otherwise you can do it very simple. I mean, this will become very easy problem. If you put 2 by 3, you can do it using graphs only without even differentiating. All right, so this was the problem, 3x minus 7. If I'm writing it correctly, this was the problem, 3x minus 7 into x raised to 2 by 3. All right, so you can just multiply this term inside and then differentiate it and check where is this derivative of f positive. All right, so this will be 3 into x raised to 1 plus 2 by 3. So 1 plus 2 by 3 is 5 by 3. All right, minus 7 into x raised to 2 by 3. Now differentiate. So it will be f dash is equal to 5 into x raised to 2 by 3 again minus 14 into 14 by 3 into x raised to minus 1 by 3. All right, this. So if you take LCM, it will be uh, just take x raised to 1 by 3 LCM. So it will be x raised to 1 by 3 in the denominator, and it will be 5x minus 14 by 3. All right, in the numerator. Yes. Now you can plot the number line. You can use wavy curve method, critical point. So critical point of the factor in numerator is 14 by 15, and critical point of the factor in denominator is 0 because it has odd p upon q, which in which p and q both are odd. So 0 is the sign. 0 is the point where this is changing its sign. All right. Plus minus plus. So you can see where this function is increasing. So it is minus infinity to 0. All right. Union 14 by 15 to infinity. So it is pretty simple. Just differentiate and you can write the answer. All right, so this was an easy problem, not difficult at all. Now let's move to another problem, question number 11. So this was a problem of parabola. So let P be a point on a parabola, y square is equal to 12x, and n be the foot of perpendicular drawn from point P on the axis only. All right, so let me draw the first, let us sketch it. All right, I am going slow so that I can explain everything properly. All right. So y square is equal to 12x. This is the parabola. All right. You can take one point on this. So as you know, a is equal to 3 in this. So 80 square comma 280 standard form. So a is 3. So 3t square comma 60. You can take one of the point, and this point is basically P. And you have dropped a perpendicular from this. So perpendicular means the axis at n. So this point will be 3t square comma 0. Then there's a point on Pn, which is m, midpoint. So you can write m as well. M will be 3t square, x coordinate will remain same, and y coordinate will be 3t, right? This is the midpoint. Then Pn parallel Pn m of Pn, okay. Parallel to its axis, okay, a line is drawn through the midpoint m of Pn parallel to axis. All right, so one line you can draw parallel to axis through m, which means the parabola at q. So this point is q. All right, this point is q. We can we find this point? Yes, we can find, because we know the y coordinate of this point. Q, y coordinate of this point is, x coordinate is say x1 and y coordinate is 3t. All right, so by putting in the, I mean, you can compare the t. So this 3t is equal to 2, 3t is equal to 2 8t1. So you'll get parameter of this point. So t1 is equal to what? A is also 3. So t by 2. T by 2 is the parameter. A is equal to 3. All right. So t by 2 is the parameter. Then s will be 8t square. So q point we have got. Q point is 8t square. So a is 3. And t square is t square by 4. All right. And 3t this. So basically half. Just put t is equal to t by 2 in this and in the coordinates of p, and I'll get q. All right. So we have got q. Then what to do with this? Then a line NQ meets the y-intercept of the line. Okay, y-intercept of the line NQ is given. So if you draw this line NQ, its y-intercept, that means y-coordinate of this point is given 4 by 3. So this point is given 0, 4 by 3. All right, y-intercept. So that means we need to write the equation of NQ, and then we can find y-coordinate, and we can equate with 4 by 3. We'll get T, and after getting T, we can find M and P and whatever we need to find. All right. So let's write the equation of this. So y minus 0, equation of Qn. All right, equation. Equation of Qn is y minus 0 is equal to y2 minus y1. So y2 is, let's take this Q point. Y2 is this 3t minus 0 upon 3t square by 4 minus this 3d square into x minus x1. So x minus, we have taken y1 is 0, so x1 is 3t square. All right, because we need y coordinate, so y coordinate of point q, so put x is equal to 0 in this, you'll get y coordinate of point q. So after putting, you'll get y1 is equal to, y1 is this 4 by 3. All right, so y1 is equal to 3t. So you can cancel 3t actually, 3 also and t also. So you'll get 1 upon, in denominator it will be t by 4 and minus t. So that is minus 3t by 4. All right. So all right, I'll write it t by 4. So t by 4, and with minus sign also. This is negative and this is positive. All right. This is negative and minus t plus t by 4. And what if we have put 0 here, so it will be minus 3t square. All right. All right. Now let's simplify it. So y1 is equal to, what is y1? y1 is 4 by 3. So let's put 4 by 3 is equal to, t you can cancel, and it is in denominator is 3t by minus 3t by 4. All right, and 3 will get cancelled and it will be 4, right? 4t. So it is 4t, and we are getting t is equal to 1 by 3 actually, right? So t, we have got t is equal to 1 by 3, and if I take t is equal to 1 by 3, then I can write this coordinate what we need. 1 minute. 3 by 4, so 4 is in the numerator and 4 by 3. Yeah. So I'm getting t is equal to 1 by 3, and if I get t is equal to 1 by 3, then I can write the y coordinate of this p. So y coordinate p point will be, p point, x coordinate of p point will be what? Put 3, so it will be 1 by 3 comma 2. All right. All right, and then you can write the coordinates of point q as well, right? Coordinate of point q will be, you can write the coordinates of point q will be what? This if you put in this is 3, put 1 by 3, so it will be 9, 1 by 1 by 12, 1 by 12 comma 1, right? And you can also write the coordinates of point m. Coordinates of point m will be, x coordinate will be same as that of p, and y coordinate will be half, so it is 1, right? So now you can see q, pn you need to find, so pn is nothing but 2, so that is not true. mq, to find mq, all right, mq is given in 2 options, so mq you need to find. Mq is basically difference of these 2 coordinates, so that is 1 by 12 minus 1 by 3. All right, so if you take this difference, this is basically 1 by 4. All right, 3 by 12, 3 by 12, and that is 1 by 4. All right, so yes, mq is 1 by 4. That is the correct option. So this was the correct option. It involves some calculation, but pretty straightforward. All right, so this is not very easy and not difficult, but yes, it involves some calculation, so it will take time if you solve this problem. All right, so time taking. Now we need to find the solution of this differential equation. So let's see this differential equation we can solve. We can solve it easily because this is variable separable type, 1 minus 1 plus e raised to minus x dy y, 1 plus y square. Now let's do the remaining questions fast. So 1 plus y square dy by dx. This is pretty simple problem. Y square, we can do it fast. So we'll get 1 plus y square divided by y square into dy, and you can write this dx upon 1 plus e raised to minus x, which you can write e raised to x plus 1, and e raised to x you can take in the numerator. All right, so now you can integrate. This is 1 upon y square plus 1 dy is equal to, this is simple f dash upon f, right? So it is going to be ln of e raised to x plus 1 dx, right? This is f dash and this is f. So now you can write the answer. Integration of 1 upon y square is minus 1 upon y. Integration of 1 is with respect to y is y. And integration of this is ln of e raised to x plus 1, all right, plus c. So you'll get, if you take LCM, y square minus 1 is equal to y into ln of e raised to x plus 1. This curve is also given passing through 0 comma 1, so we need a specific solution of this equation. So you put 0 comma 1 in this equation. If you put 0 comma 1, right hand side will be 0, this will be 1, and e raised to, if you put 0, ln of 1 plus c, so you'll get c. Ln of 1 is also 0, so c is equal to 0. So this is going to be the solution for put 0. So y square minus 1 is equal to this e square plus 1. Did we miss anything? Did we miss anything? So I think, yeah. Wait a minute. Sorry. This will be ln2. This will be ln2, not 1. Okay. So c is not 0. Sorry, c is not 0. I'm sorry. This c is going to be, yes, we'll get the value of c. C is equal to minus ln2. All right. So if I put c is equal to minus ln2, then this is c and minus ln2. Then how to divide it? This was complete brackets. All right. So then you can divide by ln2. Brackets were there because we cross multiplied by c. So these brackets were there. C was inside this bracket. All right. So I'll write it correctly. Let me erase this. Yeah, this was the equation. So if you put ln c is equal to minus ln2, it will be final answer. Let me write. So final answer is going to be this y square minus 1 is equal to y, and then ln of x is square plus 1 minus ln2, and you can club these two. So this will be the final answer. All right. So D was the final answer in this. All right. Let's move to another problem. This is again, oh, there were two problems of area. So area bounded by this curve, two curves, is equal to, let's solve it. So you have one curve is y is less than sin x. We have just finished it, right? It's a similar kind of problem. So let's draw this sin x between 0 to pi, because x is given between 0 to pi. So this is 0 and this is pi. And you have another curve, y is greater than 1 by 2 also, right? Y is less than sin x. That means y is below this sin x and greater than 1 by 2. So this is pretty simple, very simple actually. Sorry. Let's do it. This is 1 by 2, okay? Y is equal to 1 by 2. So it is above this, so this will be the bounded area. That means you need to integrate. Y is 1 by 2 when x is equal to, when is sin x is equal to 1 by 2, it is pi by 6, and pi minus pi by 6, that is 5 pi by 6. So that means you need to integrate sin x from pi by 6 to 5 pi by 6 and subtract this rectangle, all right? Area, the area of this rectangle. So 0 to pi by 6 to 5 pi by 6 sin x dx minus area of this rectangle, which is of length 5 pi by 6 minus pi by 6, this length, into height is 1 by 2. All right, so let's simplify it. It is going to be integral of cos x, sin x is minus cos x, pi by 6 to 5 pi by 6 plus, minus this is 4 pi by 6 Now 5 pi by 6 minus 4 pi by 6, 4 pi by 6 is 2 pi by 3. So 2 pi by 3 into 1 by 2, so 2 pi by 6, all right, 2 pi by 6. Now let's simplify this, put 5 pi by 6 in this cos x. So cos of 5 pi by 6, cos of 5 pi by 6 is root 3 by 2. Yeah. So root 3 minus root 3 by 2, all right. So minus root 3 by 2, so minus of minus root 3 by 2, all right. This plus you need to put minus of cos pi by 6. So minus of minus will be plus, and then again minus of minus will be, if you put pi by 6, so minus of minus root 3 by 2, which is again root 3 by 2, all right. Minus, it is, let me check this calculation again. This is 5 pi by 6 minus pi by 6, all right. So 4 pi by 6, 4 pi by 6 divided by 2, all right. So it is going to be pi by 3. So I have written it wrongly, 2 pi by 6. All right, it is fine, 2 pi by 3. So this is 2 pi by 6 is pi by 3, all right. So pi by 3. So this is final answer. Final area is root 3 by 2. Root 3 by 2 is root 3 minus pi by 3, all right. So this is the answer. So fourth is the correct answer, all right. Now let's do another problem. This is a problem of a vector. There was one problem of vector, but this, I mean, I doubt the data of this because I confirmed with the students, but yes, this is the most probable question. So I'm going to solve it. Problem was similar to this or maybe this only. Okay, I'm not sure in this particular problem, 100%. But question was this, two lines were given vector form, and about the lines we needed to find the values of L or M so that these two lines intersect or do not intersect. So just solve these two lines, just solve these two lines. How to solve them? Just equate R, okay? Equate this and this. So if you equate, this is I minus J plus L times of 2I plus K cap is equal to 2I minus J plus M times of I plus J minus K, all right? So if you just compare the coefficient of I, it is 1 plus 2L left hand side, and coefficient of I right hand side, I cap is 2 plus M right hand side, all right. This is relation 1. Now relation 2, compare the coefficient of J, which is minus 1, and no J cap here. Now right hand side it is minus 1 plus M, all right. This is the second relation. And third relation will be compare the coefficient of K, which is L left hand side and minus M right hand side. You can see here, okay, and here. That's it. So from this you can get M is equal to 0 immediately. From this you'll get L is equal to minus M, which is M is 0 now, so L is also 0. And if we put M is equal to 0 in this, I'll get L is equal to, we have three relations and two parameters. So whether equations will be consistent or not, that you need to check by finding the values of these two parameters from two equations and put in the third and check if these two values satisfy the third, then that solution will exist. Otherwise, there won't be any solution. So let's put L and M, and obviously if I put L is equal to 0, M is equal to 0, so it won't satisfy. We are getting, if I put M is equal to 0, L is equal to 0 in this equation, I'll get 1 is equal to 2. So not true, right? So that means these values will not satisfy. So there's no value of L and M. So do not intersect for any value of L and M. This is my answer, all right, with this data. So with this data, answer must be do not intersect with these values, any value of L, any value of L and M. Now let's move to another problem. This was pretty simple, a quadratic equation. Uh, the solution of this equation, when both roots are equal, we'll get the values of M, and the values of M are basically set A, and set B is given. Then we need to find intersection, difference, or union of these two sets. So let's find first set A by putting the discriminant of this is equal to 0, because roots of this equation are equal. So M plus 1 the whole square, or minus of M plus 1 the whole square, same thing, minus 4AC. So 4M plus 4 is equal to 0, and you'll get M square plus 1 plus 2M minus 4M minus 16 is equal to 0, all right. We'll get this M square minus 2M, M square minus 2M, and you'll get minus 15, all right. So you can split this m square. Okay, then let me directly factorize it to not waste time. So we can factorize it directly, and we can write this is m minus 5 into m plus 3, all right, is equal to 0. So you get mm, okay. Now I doubt with both roots were actually equal or maybe real. Let me check that. Okay, real or equal, because if real then it is very easy. So again, okay, so real and equal, it should be real and equal. I think it was real and equal. Okay, so let's make it real and equal, real and equal. All right, so discriminant we need to put more than or equal to 0, more than or equal to 0, more than or equal to 0, more than or equal to 0. It might be equal also, but I'm considering real and equal. Okay, so if I consider real and equal, then answer will be m belongs to minus infinity to minus 3 closed union 5 to infinity. All right, and second set is minus 3 to 5. All right, this is set B. Set B, this is set B, and this is set A. All right, so now see A minus B, if you subtract A minus B, so minus 3 to 5, all numbers will be removed from this set. So it will be A minus B is basically minus infinity to minus 3. Minus 3 is the only thing common, so minus 3 will be removed, but 5 is not there in B, so 5 will not be removed, so it will be 5 to infinity closed. All right, 5 is closed. But you can see in A option this is wrong. So we need to find the wrong option only. So yes, this will be the correct answer. You can check other options also. This was A intersection B. So A intersection B is what? A intersection B is minus 3 only. Yes, A intersection B is minus 3. So this is correct. This correct means wrong option. All right. B minus A. B minus A similarly you can calculate is correct, minus 3 to 5, because only minus 3 will be removed from B. So it will be minus 3 open to 5. And if you add A union B, so yes, it is going to be R. So all rest remaining options are correct. That means in this question it is wrong, because we need to find wrong option. So A will be the right choice. All right, now let's move to another problem. So this was a problem based on differentiation. So we had this equation y square is y square plus, all right, it's a lot of time, y square plus, you can write 2 ln cos x. All right, you can put mod also, no problem, is equal to y. So we need y dash 0 and y double dash 0. So just differentiate it, we'll get 2y into y dash is equal to plus 2 upon cos x into differentiation of cos x is minus sin x, right? So minus sin x plus is equal to y dash. Now you need y dash 0, so put y is equal to 0 in this equation, and also x is equal to 0, I'm sorry. So if you put x is equal to 0 in this equation, you'll get, okay, also you see if you put x is equal to 0 in this equation, you'll get ln of 0, 0, and you'll get y is equal to 0 or 1. Two values, y is equal to 0 or 1, right? If you put x is equal to 0 in this. So I don't know if anything was given about this, whether y is 0 or y cannot be 0 or y cannot be 1. I don't know. Y can be 1 also using this. All right, so we'll get this. If I put x is equal to 0 in this, if I put x is equal to 0, I'll get this 2y minus 1 into y dash plus 0 is equal to 0. So yes, y is certainly not half, okay, when x is 0, because you know y is either 0 or 1. So y is not half. So certainly y dash must be 0. So y dash 0 is 0. This is y dash 0. All right, you can write y dash 0 is equal to 0. Now we need y double dash also. So further differentiate it. Further after differentiating again, we'll get 2 y dash square plus 2 y into y double dash, and this is minus 2 cot x, so minus 2 cot tan x. The tan differentiation of tan x is sec square x, all right, uh, is equal to y double dash. Okay, now again put x is equal to 0 in this. So if you put x is equal to 0 in this, so it will be y dash of 0, which is 0. So this will become 0, plus this will be 2 y into y double dash of 0, all right, minus 2, and all right, is equal to y double dash of 0, all right. So we need y double dash of 0. Let's simplify it. So it will be 2y minus 1 into 2y minus 1 into y double dash of 0 is equal to 2, all right. So either so we can find y double dash of 0 is equal to 2 upon 2y minus 1, all right. 2y minus 1, all right. So either y double dash 0 will be minus 2 if I put y is equal to 0, because I know x is, for x is equal to 0, y is equal to 0. And if I take y is equal to 1, then y double dash will be, y double dash 0 will be minus plus 2. So y double dash 0 will be minus 2 when y is 0, or plus 2 when y is 1. So in any case, we need y double dash, of mod of y double dash of 0, which is 2, right? So this will be 2 and this will be 0, so answer is going to be 2, right? We need mod, so do not bother about plus or minus, all right? So answer is 2 in this particular question. We just needed to differentiate it. It is not difficult, but although I can see in every question there is some conceptual point involved, right? Now this is again a good question. Um, but one thing I should tell you, whenever you these are conjugates of each other, so whenever you multiply 1 minus I, 1 plus I, this is widely used, right? We use it in many questions. It is 2, right? And 1 plus I the whole square is 2 iota, right? So if I multiply by the conjugate of the denominator in this expression, 1 plus iota, then it is going to be 2i in numerator, and denominator is 2, so it is nothing but iota. That means I can write this as I raised to m by 2 plus I raised, sorry, is equal to I raised to n by 3 or minus n by 3 is equal to 1. So I raised to multiple of 4 is 1, right? Greatest common divisor of the least values of m and n. So least value, for least values of m and n, let's take m by 2 is equal to 4 we'll have to take, right? 4, it should be the least value. So m is equal to 8, and minus n by 3 should be, Mm, yeah, and also we cannot take 0. 0 should be prohibited in this question. So I think that was given in the question, that m and n are non-zero numbers. All right. So minus n by 3 should be minus 4. Okay, to keep the least positive value. Positive integers must be given in the questions. I have not written it here. So I'm assuming that m and n are given positive integers. All right, positive integers. So it, from this I'll get n is equal to 12. All right. Then you need to these are the least positive values of m and n. Then you need the greatest common divisor of these two numbers. So greatest common divisor of these two numbers, very simple, 4, right? So it is 4. All right. This was the 17 problem. Now let's do the another problem, question number 18. There's 1p0, 1, 2p1. So let's write the values. This is a series up to 50 terms added with another series with 50 terms. So first of all, let's simplify this series. NPR is n factorial upon n minus r factorial, all right? So using that, I can write the value of 1p0. This is 1 factorial upon 1 minus 0 factorial. 1 minus 0 factorial is 1 factorial, all right? Minus 3 into 2p1 is 2 factorial upon 2 minus 1 factorial is again 1 factorial, plus 3p2. So 4, in fact, let's generalize it. So n minus 1 is nothing but n factorial, all right? N factorial. So let's write it 4 into 3 factorial, then minus 5 into 4 factorial, and so on, right? This is written. So this is the first bracket, and second bracket is 1 factorial minus 2 factorial plus 3 factorial minus 4 factorial, and so on up to 51 terms. So 51th term will be 51 factorial with with plus sign, actually, because you can see odd numbers are coming with positive negative sign and even numbers are coming with negative sign, odd with plus positive sign. But in this series you can say it is 2 factorial minus, now it will become 3 factorial plus 4 factorial, and so on. You need to write 51 terms in this also. So 51 term will be 52 into 51 factorial. That is going to be 52 factorial. And in this you can see even numbers are coming with positive sign. So 52 factorial will be positive. Plus the second series, let me write the series below this. So it is 1 minus 2 factorial plus 3 factorial minus 4 factorial, so you can see everything will get cancelled, right? 51 factorial, all the terms, 2 factorial, 3 factorial, 4 factorial, and this. So only thing left is 1 plus 52 factorial. So it was very simple question, right? You just needed to open this in PR. All right, now let's do this problem of inverse trigonometry. All right, so there was a problem from inverse trigonometry. So terms are given in terms of sine inverse. So if you know the formula of sine inverse, you can solve in terms of sine inverse. But if you don't know, it should be 3 by 5. All right, 3 by 5, 3 by 5. So if you don't know the formula of sine inverse, then you change it to tan inverse and do it. Okay, let me check this number one once. There might be typing error. Then we will proceed. All right, so I suppose it should be 3, mostly it is 3 by 5, but again, let's not waste time because we have already given a lot of time in this discussion. Just a moment. All right, so let me correct it. Yes, there was a correction in this. It's good that we haven't proceeded. Now, so this was actually, now we need to correct these numbers. This is actually 13 and this is 16 as well, 16 by 65. All right, so if you have a square plus b x square plus y, x square plus y square less than 1, then you can apply this formula of sine inverse of x into under root of 1 minus y square plus y into under root of 1 minus x square. Okay, so yes, you can see x square plus y square is less than 1. So apply this formula and club these two terms at least. So after clubbing these two terms, it will be 4 by 5 under root of 5 by 13. So this is a Pythagorean triplet, 5, 12 and 13, right? Pythagorean triplet. So it will be 1 minus 5 square by 13 square is going to be 12 by 13, right? Plus it is 5 by 13, and this is also Pythagorean triplet, 3, 4, 5. Mostly you can see numbers are like this only, Pythagorean triplet. Okay, so it is going to be, you can write it directly 4 by 5, you use it too frequently, so 3 by 5. All right, so it is going to be sine inverse of, now 4 by 5 into, this is going to be 12 by 13. All right, plus it is 5 into 3 divided by 13 into 5. So let it be 13 into 5 in the denominator, and you can write this sine inverse of what, uh, 65 in the denominator, and in the numerator, let's see what is coming, 15 and 48. 48 plus 15 is 63. All right, so 63. So now we are left with this 2 pi minus sine inverse of 63 by 65 and plus sine inverse of 16 by 65. All right, all right, so it was like this. So these three numbers are also Pythagorean triplet. If you subtract 65 square minus 63 square, should be 16 square, right? 25, 65, 25. So you can check this. All right, so that means you can change this to, okay, we can check, it's no problem. You can do it a square minus b square, just apply it. So it will be 65 plus 63. All right, let's do it fast, quickly, and let's see it is 256 or not. So 8 and yes, this is 128. You can see this 128 into 2, 256, right? So yes, it is checked that these are Pythagorean triplets, 16, 63 and 65. So in this way you can check it, and after checking it, you can write cos inverse of, change either of the sine inverse in terms of cos inverse, 16 by 65 plus sine inverse of 16 by 65. All right, and you know it is pi by 2. Sine inverse x minus plus cos inverse x for all x between -1 to 1. It is pi by 2 only. So this is pi by 2, and answer is 3 pi 2 pi minus pi by 2, which is 3 pi by 2. So 3 pi by 2 the answer in this case. All right, so this was simple but calculative problem. All right. Now this was a question from mathematical reasoning, right? So we can simplify this statement. So P is given equal to negative of P and Q, you take this negative inside, you can write this negative of p or q, right? You can write like this, and now you know that p implies q. P implies q is equivalent to so equivalent to negative of p, negation of p or q, right? So here q is this thing, right? You can just replace this. P implies this minus of p or q. This can be written as equivalent to just negative of negation of p, or it will be this minus p, negative of p or q, right? So now you can see this or this, right? And this negative of p is basically a subset of this only, right? So you can whether you write this or this, both are same, right? Both are implying the same thing. So generalize, if you take union, that means union type. So it is negation of p or q, all right? This is the combined form of this. So answer is second in this, right? So this was pretty simple problem of mathematical reasoning. All right, let's solve the remaining 5 problems. Do it quickly. Let's do it quickly. So this was again a problem of basic properties of log. This is a GP, so you can find the sum of this GP. So it was 0.16 can be written as 16 by 100. 16 by 100 you can write as 4 by 25. So yes, 4 by 25. Let's write this 4 by 25 raised to. Now let's keep simplifying. This base is 2.5 is 25 by 25 by 10. 25 by 10 is 5 by 2. All right, 5 by 2. Can you see these numbers? Yes, they are related. Okay, base of exponent. And let's write the sum of this series 1 by 3 upon 1 minus 1 by 3. It's a GP, simple GP. This you can write in terms of 5 by 2. So you need to write 5 by 2 the power minus 2. All right. So minus 2 will be there. Log of what is this sum? This sum is going to be 1 by 3 upon 1 by 3. So it is going to be 1 by 2. All right. And this is 5 by 2. Just take minus 2 here. And then you can write using this property a raised to log of x base a is nothing but x, right? So it is going to be 5 by 2 to the power log of 1 by 2 to the power minus 2 to the base 5 by 2, and it is going to be 1 by 2 raised to minus 2, which is nothing but 4. All right, so it is integer type. 4 is the answer in this. All right, now let's move to another problem, which is problem of limits. So I think this was integer type of problem. So 5 integral types of problems were there. Now this expression you can compare with minus 1 minus a minus b plus abv. This is a problem which you can see on in almost in all the books and assignments. All right. So 1 minus a minus b plus ab can be written as 1 minus a into 1 minus b, but it is a good problem. All right. So using this, you can directly, if you, this is a pretty simple expression, but it is widely used. All right. So just remember it, and using this, you can have an idea that this expression can be written as 1 minus cos of x square by 2 and 1 minus cos of x square by 4. 1 minus cos theta 1, 1 minus cos theta 2. All right, divided by this x raised to 8. You know 1 minus cos theta is 2 sin square theta by 2. So 2 sin square theta by 2. I'm writing this whole square, and this will be 2 sin square theta by 2. So it will be, oh, I have not done theta by 2. Theta by 2 means it will become theta by 4. All right. So theta by 4, and this is going to be theta by 8, all right, the whole square, and divided by x raised to 8. So whenever theta is approaching to 0 and sine terms are in product, so just for do it quickly, you can replace sine theta by theta. So you can write this 2 into x square by 4 the whole square, x square by 8. I'm just replacing sine theta by theta, okay, in this product. In product you can do this, x raised to 8, all right. So now you can see x raised to 4, x raised to 4, and total x raised to 8, 8 will get cancelled, and it is 2 into 1 upon 4 square. All right, 1 2 was also there, so into 2 let me write, and 4 square and 1 upon 8 square into 2. So finally in terms of 2, it is going to be 2 raised to 6. This is 2 raised to 6, and this is 2 raised to 1 4 will get cancelled, so 2 and 2 this. So 2 raised to, so total 2 raised to 8, which you can write 2 raised to minus 8, and it is given equal to 2 raised to minus k, so you can write k is equal to 8. Okay, so answer of this was 8. Good question, good question. So few questions were very easy, but this is also easy, but again every question is involving some good point, all right? Some kind of calculation where you can commit some error, definitely. So questions are, this paper is not, I won't say this paper is easy. This paper is, I mean, moderate to slightly difficult also, you can say, but certainly moderate, medium average level. All right, so this was a problem of matrices problem, and we need a raised to 4. So obviously a is given and we need a raised to 4, and what is actually required is a22, this element. Okay, so obviously we'll have to do squaring and see this element in a raised to 4 is given to, which can be used to find x also, right? Because obviously a raised to 4 will come in terms of x only. So let's first find a square, which will be x110 into x110. The good thing is that it is 2 by 2 matrix. We can multiply it easily. Okay, row by column. So it is x square plus 1, and then it will be x only, then it will be x only, then it will be 1 only. All right, now let's do a raised to 4 by writing a square into a square. So I'll write x square plus 1, x1, x square plus 1, x1. All right, and let's write only these two elements because this and this are our main point. So this element will be multiply. So x square plus 1 the whole square plus x square. Yeah. Leave this and directly write this last element. Last element will come by multiplying these two. All right. So if you multiply second row, second column, so it will be x square plus 1, x square plus 1. All right. So A22 is nothing but x square plus 1, but before that we need x square plus 1, and x square plus 1 you can find using this x square plus 1 the whole square plus x square is equal to 109. All right, so put x square is equal to t and expand it, so it will be t square, t square plus 2t plus 1 plus t is equal to 109, and simplify this quadratic, so it will be t square plus 3t minus 108. All right, is equal to 0. So you can split this in 12 and 9. So this can be written as t plus 12 into t minus 9. All right, so you'll get t is equal to 9 because t is a positive number, so t is equal to 9 will be the solution, and t is nothing but x square. So if you put in this will be 9 plus 1, 10. So 10 is the answer. Answer of this is 10. All right, now let's move to another problem. So this is a problem of a lengthy problem. All right, because you need to express this in terms of cubic. So you'll have to do that operations rows and column, and after doing that you'll get the answer. All right, so it's pretty straightforward. I want to leave it, but okay, I'll do some steps. So you can, to simplify it, you can write r2 minus r1, r2 minus say 2r1. Okay, 2r1, if you subtract twice of this, this x will get cancelled, and yeah, let me check if that works. Yeah, this will become a constant, and let me also check the numbers first of all, because in this there might be some calculation error as well, right? Yes, the number seems all right. Yeah, yes. Okay, so whatever problem I have, this is correct. So if I do 2 times of r1, so at least this element will become constant. All right, and similarly, I can also subtract this. Sorry, I can write this r3. This is r2 is replaced by this. Okay, r3 can also be replaced by r3 minus. mm Yeah, 3 times. Let's do this 3 times. 3 times so that at least this element will become. So let me subtract it. So it will be x minus 2, 2x minus 3, all right, and 3x minus 4. And after subtracting it twice, so 2 times of it will become 1 only, right? It will become 1, and what will be this element? 2 times of, so minus x will come, and 6 plus 6 and minus plus 2, all right, and this will be 6, so minus 2x, all right, and plus 8 minus 5 is plus 3, all right, this, then thrice of r1 from r3, so it will be 6 minus 5, 1, all right, and then this will be 6 times of, so minus x, all right, minus x, 9 plus 1, all right, plus 1, and this is going to be x 12 plus 12 minus, so minus 5. All right, this is going to be, now again you can make 0, right, and then you can write the answer. So I'm telling you the answer, then you can simplify it and then compare the coefficients right hand side. So in this b minus b and c, b plus c was coming out to be if you after comparing minus 3 and you need modulus, so answer was 3, all right, modulus of b plus 3, because it is a lot of time has also already been happened, and this is not a, I mean, controversial problem. This is pretty straightforward. Now let me do this last problem. This is pretty simple, so I'll do it fast. All right, so we are almost done. So this line is x plus y is equal to, I suppose it was 3, not 2, all right. So x plus y is equal to 3. This is x plus y is equal to 3. And this is also y is equal to 3. Then this line, let me make this diagram again. X plus y is equal to 3, so this point is 3 comma 0 and this point is 0 comma 3, and two lines, one line is y is equal to 3 and other is x is equal to 3, all right. So these are the three lines. Center of the circle lies on this line and touches these two. So if I make a circle, you can see this point is 3 comma 3, so this is nothing but a square, all right. So circle is going to touch these two. Let me make the circle properly, and actually this problem can be solved directly using the diagram. See how I am making this circle which is touching both the lines. So this will be the radius of the circle, this will be the radius of the circle, all right. So these two numbers are equal, radius and radius, and radius actually we need to find radius only. If these two are equal, and you can see these two triangles are similar triangles, right, so they will become congruent triangles. Congruent, I'm talking about these triangles. I'll make a big diagram. Because this is R and this is also R, right? So you can see this is going to be the midpoint, all right? Equal distance from this side, this line and this line. So it is going to be a square. This only can happen when this point is a midpoint of this line, all right? Midpoint. So this point is going to be 3 by 2 comma 3 by 2, all right? 3 by 2 comma 3 by 2. So if it is 3 by 2, then this is going to be, radius is also going to be this is a square, right? This is a square. If you take this point center, if you take here, then obviously these two distances are not going to be equal, all right. So that is the logic. So r is equal to 3 by 2 and you need diameter, so diameter is equal to 2r, which is equal to 3, all right. So this was pretty simple. So this was the paper, which is not easy. If I say uh, I took time to, because I was explaining the things, but yes, it can be done in 1 hour. Problems are not very difficult, but calculation wise and some points where I can do mistakes, including all those things, I will say that this question paper is medium level. Medium level maths is not easy, not very difficult, all right. So I hope you enjoyed it, and I hope that questions I have discussed are same which came in the exam, all right. Thank you very much for watching this video. Thank you very much.